Okay, welcome to our third lesson in Lenzs Law. Now I'm going to use the keynote presentation here, so just to mix things up a little bit. So in this problem, we've got two coils. One of them, the blue one, is sitting right next to the black one. And this represents the initial state of the problem. So I've just got two coils of wire sitting side by side and nothing is happening. So in that black coil, there is no flux through it at all. What we want to do, we're going to actually create a current in the blue coil, and that's going to produce a flux which will affect the black coil, and it's going to produce a current in response. And we want to work out what way that current in the black coil is going to travel. So let me show you what I mean. So this is the initial situation where you've just got two coils and nothing happening. In the second situation, or in the final situation, we have connected the blue coil to a battery. Now notice that the long line of the battery is the positive side and the short part of the battery is the negative side. And so that's going to produce a current around the coil like that. Now we're going to from now on call the blue coil the primary coil, and the black coil we will call the secondary coil. So now we've got a current flowing in our primary coil. And as we know, if there is a current flowing through a coil, that's going to produce a flux. It's going to produce a magnetic field. And we can use the right-hand grip rule to work out which direction that field is going to travel in. So if we use our right-hand grip rule, remember the thumb will point in the direction of the current and our fingers will curl around the conductor. So if you grab that primary coil with your thumb pointing in the direction of the purple arrow, your fingers will thread through that primary coil going to the left. And so we end up with a flux through the primary coil heading off to the left, like that. Now, look at the black coil, the secondary coil. Because it's very close to the primary coil, it can feel that flux that's been created in the primary coil. It can feel it because it's very close. And so what's happened is that secondary coil, initially there was no flux at all, but now there's a flux flowing through it to the left. So what's it going to do? How's it going to respond to that? Well, Lenz's law is going to allow us to work that out. So we now know that the initial flux was zero and the final flux through that secondary coil is pointing to the left. So let's use that four-step process to actually work out which direction the induced flux will travel in. Now, you might want to pause the video now to see if you can work it out yourself and then come back and see if you're correct. Okay, welcome back. So let's have a look at this. The initial flux we know was zero. And after we turned on the battery, that flux was created and it created a flux pointing to the left through our secondary black coil. So remembering that the change in flux is the final plus the negative of the initial, well, because the initial was zero, our change in flux will be in that direction as well. So the change in flux is pointing to the left through that black secondary coil. So which way will the induced flux be? Well, remember, Lenz's law tells us that the induced flux will always oppose the change in flux. And so if the change in flux is pointing to the left, then the induced flux has to point to the right. And so the induced flux will be to the right. And in that case, if the induced flux through that secondary coil has to go to the right to oppose the change, we can now use the right-hand grip rule in reverse to work out the direction of that current. So if you now get your right hand and imagine you're sticking your fingers, which is the direction of the field lines, the flux, through that coil, and you're gripping the conductor, the direction of your thumb will show you that the current is flowing in that direction. So once again, we've used Lenz's law to show you which way the current will flow in a coil where we've changed the flux that's passing through that coil. Okay, that concludes our second example.